There are roughly 1,100 working artificial satellites orbiting Earth as we speak, helping us navigate and forecast weather, making observations of space, and beaming down TV shows about duck hunters and aspiring singers. But some of you have asked, how do artificial satellites get up there? And more importantly, how do they stay up there? Well, before we talk about rockets, let's talk about cannons. Imagine you fire a cannon horizontally off a mountaintop. The cannonball would fly parallel to the Earth until gravity pulled it back down to the ground, right? Now, imagine adding more and more gunpowder. The cannonball would fly farther and farther before it falls until, with enough gunpowder, it would eventually circle the Earth. Sound preposterous? The fact is, this little thought experiment, first conceived by Isaac Newton, was the first step toward figuring out how to get satellites into orbit. We send each one up on a rocket, called a launch vehicle, that travels straight up for only a short time before it starts to tilt into a curved trajectory that brings it nearly parallel to Earth's surface. The tricky part, once it's up there, is finding the balance between gravity and velocity, because Earth's gravitation is pulling the satellite back down while at the same time it's speeding forward. In order to stay at its right altitude, it's all about orbital velocity, the proper speed that creates a stable orbit based on its altitude. It's a delicate balancing act. Too fast and the satellite will escape Earth's gravity and fly off into space. Too slow and it'll be pulled back in and probably burn up on re-entry. If a satellite is closer to Earth, it must travel faster to maintain its orbit. Most artificial satellites fly in low Earth orbit, which is between about 150 and 2,000 kilometers in altitude. So satellites in low Earth orbits, say about 300 kilometers, have to book it at almost 28,000 kilometers an hour. Whereas those that are 1,000 kilometers up move at the relaxed pace of only 25,000 kilometers an hour. Of course, it's never easy. Satellites have to watch out for orbital decay, the process that leads to a gradual decrease in their altitude. This is mostly due to atmospheric drag, caused by collisions with gas molecules in the atmosphere. All artificial satellites orbiting the Earth are close enough to feel the effects of drag to some degree. The International Space Station, for example, orbits at about 400 kilometers above Earth, but it loses 90 meters of altitude a day. It counteracts this by periodically firing two of its onboard engines, and every time a resupply vessel stops by, it gives it a little extra boost into a higher altitude, extending its orbital life a little longer. It's at lower orbits where things get really hairy. The atmosphere is denser at lower altitudes, which causes more drag, and more drag means even lower altitude. It's a nasty runaway cycle. This is what brought down Skylab, NASA's first space station in the 1970s, and eventually every satellite is going to face this fate. Sometimes a satellite near the end of its career will be deorbited, or basically forced into a controlled re-entry. More often, though, it's more fuel efficient just to boost it up into what's known as a disposal orbit. In this case, the decommissioned satellite is moved out about 300 kilometers from its original flight path, out of the way of working satellites, into its final long, slow orbit. Hundreds of satellites are now circling around in this orbiting graveyard. But since they're all experiencing the effect of Earth's atmosphere, they're going to come down at some point. It's just a matter of when. Objects in low Earth orbit could fall back to the planet in a matter of years, whereas ones higher up will experience orbital decay on a scale of decades or even a century or more. The good news is that most of that junk will burn up on re-entry. For the bigger stuff that doesn't, all I can say is don't blame us. This was all Isaac Newton's idea. Thanks for joining me for SciShow Space. If you want to learn how you can help us keep exploring the universe together, just go to subbable.com/scishow. And don't forget to go to youtube.com/SciShow Space and subscribe.